GATE 2014 Civil Engineering Set 2 Question 43. A rectangular channel of 2.5 meter width is carrying a discharge of 4 meter cube per second. Considering that acceleration due to gravity as 9.81 meter per second square, the velocity of flow corresponding to the critical depth at which the specific energy is minimum needs to be found. The relevant NPTEL reference has been listed. So considering the graph of a specific energy where E is plotted on the y-axis and the depth is plotted on the horizontal axis. The graph looks like this. So this specific energy is given as the sum of the potential plus the kinetic head. This can be written as E equals y plus v square. So v is nothing but q square by a square into 2g. As q is the product of a and v, so v will be given by q by a. From this we can differentiate this with respect to y, since we want the specific energy to be minimum. So this would give us 1 minus q square by ga cube into dA over dy. This value should be equal to 0 since E is minimum, so the derivative should be 0. This would give us 1 equals q square by ga cube into dA by dy. It can be seen that A will be equal to the product of the width and the depth. So dA by dy would be equal to b. Substituting that value here, we would get 1 equals q square b into g by a cube. A would be equal to b into y. From this we would get the cube of the critical depth as q square divided by g times of b square. From this we can get the critical depth as q square by gb square raised to the power 1 by 3. This equation will be utilized in solving this problem. So in our case, the width has been given as 2.5 meter, discharge is mentioned as 4 meter cube per second, and the value of a small g has been given as 9.81 meter per second square. So yc is equal to q square by gb square power 1 by 3. Substituting the values, q as 4, g as 9.81 and the width as 2.5. This would turn out to be 0.639 meters, which can be approximated as 0.64 meters. Now the discharge will be equal to the area into the velocity at the critical flow. Using this we would get 4 equals, the area would be the width into the depth into the critical velocity. So this would become 4 equals 2.5 into 0.64 into the critical flow. So Vc would turn out to be 4 by 2.5 into 0.64. This would be around 2.5 meter per second. So the velocity of flow corresponding to the critical depth at which a specific energy is minimum is 2.5. The relevant NPTEL reference has been listed.